Let's have a look at this sequence. That's a little bit different, and we'll see why it's a little bit different when we draw it out in our table as usual. So if we have n and the term which corresponds, first term, second term, third term, fourth term, fifth term, 2, 9, 18, 29, 42. And let's look at our differences. We've got plus 7, plus 9, plus 11, plus 13. So as you can see, these are all different. There is no common difference, which means it's not a linear sequence. It's actually a quadratic sequence, and I can tell that because my second difference is constant. Okay, so my second difference is constant. So this is going to be a quadratic sequence, and I could tell that if I sketch that on a graph too, like this. So if I plot these points with n and tn as my axes, like this, then my first point is at 1, 2, and my next point at 2, 9, etc. And my last point doesn't actually fit on my particular grid. And hopefully you can see I'd be unable to join these with a straight line, and in fact would be more parabolic in nature. It's quite hard to see because it's quite steep, but it would eventually look something more like this, and in fact if I went beyond the axes we'd probably eventually come back up again. So we're looking at a quadratic sequence similar to a quadratic graph. Now that's all very well, but what's that tell us apart from it's going to look something like this, ax squared plus bx plus c. In fact, it's not going to look like that because we've got n's instead. So it'll look like something n squared plus something n plus something, and that'll be my nth term. Well, how do I figure out what the coefficient of n squared, n, and what the value of c is? Okay, I've got a few different methods, but I'm going to show you one particular method. First of all, both the values of a and c are quite simple to get. First of all, the value of c, similar to with a linear sequence, can be found by finding the 0th one. And you can see the pattern here is odd numbers each time, so it's going to be plus 5, so it'd be negative 5, take away 5 to go that way, take away 5, which would be minus 3, negative 3. Okay, so that's going to be my value of c. And my value of a is also quite simple. It's half my second difference. So half second difference is a. So 2 divided by 2 is 1. So my value of a is 1. So I know what that is as well. So all I'm left with now is to find the value of b. So let's just rewrite what we know and go from there. Okay, that's it in full, and I'm just going to write it out more mathematically now. And we can now just use any of our terms to substitute it in. So for example, when n is 1, t of n is 2. So 2 equals 1 squared plus b times 1 minus 3. So 2 equals 1 plus b, take away 3. So 2 equals negative 2 plus b, and to get b on its own you add 2 to both sides, so b equals 4. And I'm just going to check that by checking if b is 4 also works for another of my terms, because if it doesn't, I've made a mistake. So let's look at our second term. So our second term is 9 equals n squared, so 2 squared plus b times 2, take away 3. So 9 equals 4 plus 2b minus 3. Well, 4 minus 3 is 1, so 1 plus 2b equals 9. And if I take away 1 from both sides, 2b equals 8, which means b equals 4. So this is going to be my expression, my equation for the nth term. Nth term is n squared plus 4n subtract 3. Let's look at one more example to practice. Here's our sequence. We're going to start off with our table of values. And we're going to find our differences. Our first differences aren't constant, so we'll find the second differences. And these are constant, so we know it will be a quadratic sequence. To find our value of A, we simply halve the second difference. So that's my value of A. And to find my value of C, I simply find the 0th one here. Well, I've added 9, then 15, then 21, then 27. So here would be 3. And because I'm going this direction, I'm going to take away 3. So that's 0. So my value of C is going to be 0. So now I've just got my value of B. And I'm going to use my adapted formula. And I'm going to substitute in n equals 1. So my nth term for n equals 1 is 3. 3 equals 3 lots of 1 squared plus b lots of 1. So 3 equals 3 plus b, while b has to equal 0. Let's check if that is true for my second value here, my second term. So I've got Tn equals 3n squared plus bn. So 12 equals 3 lots of 2 squared plus b lots of 2. So I've got, well, 2 squared is 4, so that's 12 plus 2b. If I take away 12 from both sides, 2b equals 0, so b has to equal 0. So my final term, nth term formula is going to be nth term equals simply 3n squared.